Hydrocephalus, this is a condition that's also known as water on the brain, is a main problem in Africa, especially sub-Saharan Africa, where every year more than 100,000 infants develop this disorder. If left untreated, this condition has a devastating effect. It may cause blindness, it may cause damage of the brain, and ultimately it may cause death. MRI is the preferred tool by doctors to detect hydrocephalus and determine the treatment based on that. Conventional MRIs are out of reach for Africa because of their cost, their sheer cost, and high maintenance. The goal of the research is to make a cheap MRI that is easy to use, that is of sufficient quality to diagnose hydrocephalus, and that can be used, for example, in mobile clinics.
So as Martin said, these superconducting magnets are far too expensive and high maintenance for Africa. So we're going to be using a new approach with small permanent magnets. These are much lighter, they don't require cooling, and much lower maintenance. We think that we can come up with a prototype for about 10,000 euros, and this is in comparison with a few million for a superconducting magnet. So we have developed a small Hallback magnet here. This is obviously much smaller than we're going to need for the children, but it's enabled us to test out all of the software and all of the hardware and that we're going to use for this project.
There are basically two major challenges in this project. The first one is that the magnetic field is of a much lower strength, and therefore the signal-to-noise ratio is smaller. And the second one is that the field is inhomogeneous, much more inhomogeneous than in the standard MRI. And so both these problems have to be addressed in processing, and that also makes the approach cheap, because we do not make stronger fields or perfect fields, but we solve the problem in the processing.